In this video, we look at some typically phrased problems from section 6.4, area functions, and the second fundamental theorem of calculus. Okay, and here's a couple several typically phrased problems. Okay, and the key for these kinds of problems is to remember that if you take the derivative with respect to x of the integral of some function 0 to x of f of t dt, that the answer is little f of x. Okay? Which means that the integral from 0 to x of f of t dt is an antiderivative of the function f of x. Okay? That's what it means. If you take the derivative of some function, right, and you get the function little f of x back again, right, that means that that function was an antiderivative, which is why the textbook has been typically calling that integral 0 to x of f of t dt, they've been calling that capital F of x. Okay? So, that is what you need to remember. And let's take a look at this problem and let's try to figure out how to apply what we've learned here. Okay. The question is, they want us to find some function f of x. That's what you've been asked to find, f of x. Find f of x so that 1, the derivative of that function is sine of x squared. What function can you come up with that has a derivative of sine of x squared? And 2, that function, when you evaluate it at 0, is supposed to give you 7. That's what we're being asked in this question. Okay? So, let me erase this part here. We're going to remember that the area function is an antiderivative of the integrand of that area function. Okay. Which means that if we're trying to find a function whose derivative is sine of x squared, right, just check something. Let's think ahead. If I make a function 0 to x of sine of t squared dt, I'm just going to make this function f of x like we've done in all the previous videos. What is, if you make this function f of x, what is f prime of x? By the second fundamental theorem of calculus, the answer is sine of x squared, which is equal to f of x, which is equal to, the function that the textbook is calling f prime, right? Which is sine of x squared. Okay. So we have found a function, okay, that has a derivative of sine of x squared. Okay? And therefore, that function that you can take the derivative of to get sine of x squared is the integral from 0 to x of sine of t squared dt. Okay? But we have a problem here, so that satisfies the first condition. Right? If you make this function, okay, you don't have to call it big F anymore because the textbook wanted us to call it little f. Basically, we're looking for a function that you can take the derivative of to get this. And here is an example of it. So it meets the first condition. But what about the function evaluated at 0. Does it equal 7? Does this function equal 7 when x is equal to 0? Well, if you take this function and put in 0 for x, the integral from 0 to 0 is 0. Okay. So the question that we have made, the function we have made, does not equal 7. So we need to find some way to adjust to that function so that when you put in 0, you get 7. And the easiest way to do that is to take your original function and just put on a constant 7. Okay. So now we can see if this is our guess. This is my guess at the function. Okay. Let's check. When I take the derivative of this function, do I get sine of x squared? The derivative, you can take the derivative of each piece separately. The derivative of 7 is equal to 0. And the derivative of this integral, according to the fundamental theorem of calculus part 2, is the sine of x squared. Sine of x squared plus 0 is sine of x squared, so the first condition is true. If you evaluate this function that we've just written down at 0, you'll get 0 plus 7, which is 7. Okay? So there is the answer to number 4. Sorry, I'm trying to erase here. There we go. The answer to number 4 is that the function f of x that meets those two conditions is the integral from 0 to x sine of t squared dt plus 7. Okay? Now, that will probably be a very unsatisfying answer. Okay? If you are looking to have nice answers to these problems. But the previous videos have hopefully set us up for the fact that not all functions are nice. This is an example of a function that is defined by an integral, and this is your answer. Okay? You can try to make it nicer if you wish. The problem with that is, right, let me move this to the other screen. Let's take a look at Wolfram alpha. Right? Try to write this function as something nicer. So the answer is the integral of sine of t squared from t is equal to 0 to t is equal to x plus 7. See, the 7 got interpreted funny. So let me just do the integral from 0 to x. Okay? And then add 7 to this answer. Right? And that's why the integral from 0 to x is not a nice answer. The answer is the Fresnel sine integral. That is this function. Does not have a closed form. Okay? And yet, I can write down my answer right here. This integral is a perfectly acceptable answer. Okay? The next answer is similar. Okay? The next problem is similar to this one. That the answer to it is not going to be an answer that you can write down in closed form. And yet, you can write the answer as an integral. So can you think of a function whose derivative is the sine of x divided by x and whose value at 1 is equal to 5? Okay, so let's take a look here. F of x. What function can you take the derivative of to get sine of x over x? Well, the easiest way to do that is to do an integral. How about the integral from 0 to x of sine of t divided by t dt? Right? What happens when you take the derivative of this function? Second fundamental theorem of calculus says that you should get sine of x divided by x. Okay? So that's good. We found a function, here it is, right, where the derivative is sine of x over x. Okay? So that's the first thing that we needed to check. Okay? The second thing that you needed to check was the value of this function at 1 equal to 5? Okay? So if you put 1 into the function that we just wrote down, you'll get the integral from 0 to 1 of sine of t over t dt. Yikes. Is that equal to 5? Ooh, I don't know about that. I really don't know. I'd have to graph sine of t over t and try to find the area under it from 0 to 1. Okay? I doubt that the answer will come out to be 5. Okay? So the question is there an easier way, right? Is there an easier way to find a function whose value at 1 is equal to 5? Okay? Well, the second fundamental theorem of calculus does not require that you have to have a 0 here. You can put any number a. Okay? And how about if we put a is equal to 1? Okay? The second fundamental theorem of calculus says that the derivative of the function from some constant a equals 1 in this case to x of sine of t over t dt is equal to sine of x over x. So we're still good. Now put in 1 into this function. What do you get? You get the integral from 1 to 1 of sine of t over t dt, which is equal to 0, which is not equal to 5. So the last thing you need to do is just to chuck on a 5 onto this problem. And there will be your answer to number 5. Okay? Your answer is that the function that you're looking for, the function whose derivative is sine of x over x and whose value of the function at 1 is equal to 5, this is the answer. Okay? And again, that may not be an answer that you can write down in closed form. Let's take a look at something real quick. Okay, let's go back to Wolfram alpha. Is this actually an integral that we can do? What's the integral of sine of t over t, sine of t divided by t, from t is equal to 1 to t is equal to x? Is this actually a function that we can write down the antiderivative of? And there you go. The computer says that the answer to that problem, okay, is capital SI of x minus capital SI of 1, and then if you add on the 5, that will be your answer. Now that's rather unfortunate because this is not a function we've seen before. What is capital SI of x? What is this function? Okay. Turns out that that function is the integral from 0 to x sine of t divided by t dt. So the computer, Wolfram alpha, is giving you your answer in terms of an integral defined function. The integral of sine of t over t from 0 to x, that is the meaning of SI of x. okay, which is the sine integral function. Okay, so this is the sine integral function. Okay, and those are two typically stated problems from the textbook in section 6.4.